In this video, we are going to find the exact values of trig functions that are of 30 degrees or 60 degrees. 30 degrees is also pi over 6 radians. 60 degrees is pi over 3 radians. To do that, we're going to use our special 30, 60, 90 right triangle, which I've drawn in the upper left-hand corner. We can flip it around if we want to put the 60-degree angle in the lower left-hand corner to make it a 60, 30, 90. The smallest side is always across from the smallest angle, so 1 is always across from 30 degrees. In a 30, 60, 90 right triangle, the hypotenuse is always twice the small leg, and that, by the Pythagorean theorem, means that the short side, or the long leg, is going to be the square root of 3. Let's solve that. I'm drawing these in quadrant 1 since they're reference triangles. I'm using all acute angles for them. We'll use these triangles to help us find trig values in other quadrants later because they'll be used for reference. Okay, so I've made a chart already of the sine, cosine, and tangent values of 30 degrees and 60 degrees using my triangle here. You're going to want to write those down for your notes. Notice that because 30 and 60 are complementary angles, that the cofunctions here are equal. So we have that from our complementary angle theorem that we already learned, that the sine of 30 degrees needs to be the same thing as the cosine of 60 degrees. And the cosine of 30 degrees needs to be the same thing as the sine of 60 degrees. The tangent of 30 degrees needs to be the same thing as cotangent of 60 degrees. The cosecant of 30 degrees needs to be the same thing as the secant of 90 degrees. The secant of 30 degrees needs to be the same thing as the cosecant of 60 degrees. And the tangent of 30 degrees needs to be the same thing as, sorry, this says tangent, it needs to say cotangent. The cotangent of 30 degrees needs to be the same thing as the tangent of 60 degrees. There you go. So there's, you can see that in the, with the triangles that, for instance, with sine, that it was opposite over hypotenuse here for the 30-degree angle. For the 60-degree angle, it's adjacent over hypotenuse. And you can see that that is the ratio involving the same sides. For one of the angles, it's opposite over hypotenuse, and for which is sine, and for its complement, it's adjacent over hypotenuse, which is cosine. And that's why the complementary angle theorem, we can just see that it works out with our triangle there. All right, let's go ahead and just look now. Cosine of 30 degrees is root 3 over 2. Cotangent of 60 degrees is root 3 over 3. Cosecant of, that's the same as 30 degrees. That's going to be 2. Secant of pi over 3 would be secant of 60 degrees. So that's also going to be 2. Now, if we have our function as tangent of, and our angle is 30 degrees, secant of 30 degrees is going to be 2 root 3 over 3. Now our function is sine. Ooh, we want sine of 2 theta. We haven't done this one yet, but if I take 2 times 30 degrees, that's 60 degrees. So let's find the sine of 60 degrees. So that's going to be root 3 over 2. Now I want to find sine squared of 30 degrees. So I'm going to take the sine of 30 degrees, and I'm going to square it, and that's going to be 1/4. I want 12 times the sine of 30 degrees, so 12 times 1/2 is 6. Now I want 5 times the cosine of 30 degrees. It's going to be 5 root 3 over 2. Let's find the sine of 30 degrees divided by 10. So 1/10 of 1/2 is going to be 1/20th. And now let's find 1/10 of the cosine of 30 degrees. That's going to be √3/20. Now we're going to do the same kind of thing with 60 degrees here. So cosine of 60 degrees, let's look at our chart, is 1/2. Cosine of 60 degrees, quantity squared. 1/2 squared is 1/4. 8 times the sine of 60 degrees is 8 times √3/2 is 2 goes into 8 4 times. So that's 4 times the square root of 3. 7 times the cosine of 60 degrees is 7 times 1/2 is 7/2. 1/8 of the sine of 60 degrees is going to be √3/16. And 1/10 of the cosine of 60 degrees is going to be 1/20. Now we're going to put some stuff together from the last video we did with 45, 45, 90 and with 30, 60, 90. So let me go ahead and draw my 45, 45, 90 right triangle for you again. And these values were that sine was √2/2, cosine was also √2/2, tangent was 1, cosecant was √2, secant was √2, and cotangent was also 1. So let's take cotangent of 45 degrees, that's 1, minus the sine of 60 degrees, that's √3/2. We can leave it like that, or we can write it over a common denominator of 2 minus √3/2. We want to leave it just like that. Cosecant of 60 degrees is 2√3/3, minus cosine of 45 degrees is √2/2. We could leave it like that, but let's make a common denominator here of 4√3 minus 3√2/6. Now let's take the cosine of 60 degrees, which is 1/2, plus the tangent of 60 degrees, which is √3/1. We'll make a common denominator, make that 1 plus 2√3/2. Sine of pi/3, which is sine of 60, √3/2, minus cosine of pi/6, that's cosine of 30, is √3/2. These were co-functions of complementary angles, so we knew they were congruent. When we find their difference, we get 0. Tangent of pi/6, tangent of 30, that's √3/3, minus sine of pi/3, so that's √3/2, is going to be 2√3 minus 3√3/6, or a negative √3/6. Now, we have some work to do here with this one. We need to change everything into 30 degrees or 60 degrees, or we can let's just evaluate it with the numbers that we have. That's okay. We don't need to use our complementary angle theorem. Sine of 30 degrees is 1/2. We're going to square that. Sine of 60 degrees is √3/2. So this is going to be 1 minus 1/4 minus 3/4 is 1 minus 1 is 0. If we'd used our complementary angle theorem, we would see it was going to work out that way. Go ahead and do these last few problems here. 1 plus cotangent of 30 degrees squared minus secant of 45 degrees squared. It'll be 1 plus 3 minus 2. 1 plus 1 is 2. Now 3 times the cotangent of 45 degrees squared plus 8 times the sine of 30 degrees squared is going to be 3 plus 8 times 1/4. 1/4 of 8 is 2. 3 plus 2 is 5. Now we want the sine of 60 degrees squared, that's a 3, it's a √3/2, minus cosine of 45 degrees squared. Minus sine of 30 degrees squared. I'm going to write them all with denominators of 2. So this is going to be 3/4 minus 2/4 minus 1/4 is going to be 3/4 minus 3/4 is going to be 0. And we're all done with our special right triangles. We'll come back and we'll do some problem solving next time.